welcome. It's Chaks Solution. This is vector 2, angle between two lines, right? So if we have two lines that we have, alright, so we can have an angle of theta here, and we can also have an angle of 180 minus theta. So theta is an acute angle, and 180 minus theta is an obtuse angle here. So the angle is determined by the direction vectors here. So you can say cos theta is equals to d1 dot d2 here, where d1 dot d2 is the dot product of the direction, or over the modulus of d1 times modulus of d2 here. Alright, so let's look into something here. We are saying, let's say we have d1 with this direction and d2 with this direction vector here. So now we need to find the dot product here. So the dot product here for d1 dot d2 is going to be 1 times minus 3, which is 1 times minus 3 here, then 2 times 2 plus 2 times 2 here, plus 3 times 3 plus 3 times 3 here. Then we simplify, we are going to have 10. So dot product of d1 and d2 is equals to 10 here. Right, then we look on the modulus. So modulus is the magnitude of a vector, or the length of the vector. So direction 1 here, the modulus is 1 squared plus 2 squared plus 3 squared, so which is going to be root 14. Then modulus for d2 is minus 3 squared plus 2 squared plus 3 squared, which is equals to root 21. So to find the modulus is very simple. It's just take the x component squared plus the y component squared plus the z component squared under the square root. Then that's how you find the length of the vector. Alright, so let's go to the example that we have here. Find the angle between line M and N, where M is such that R is equals to 2 minus 3 plus lambda 2 minus 2 here. Then line N is equals to 0 1 2 3 plus lambda 1 minus 2 5 here. So now we need to find the angle between these two vectors. So the first thing is to extract our directions here. So our direction for the first line is 2 minus 2 here. Then the direction 2 is 1 minus 2 5 here. Alright, so now cos theta here is equals to d1 dot d2 over the modulus of d1 times the modulus of d2 here. Alright, so now we can perform our simplification. So the dot product here is very simple. So 2 times 1 is 2, plus minus 2 times minus 2 is 4, plus 2 times 5 is 10 here. Then the modulus of the direction 1 here is going to be 2 squared plus minus 2 squared plus 2 squared, which is equals to root 16, times the other modulus here is 1 squared plus minus 2 squared plus 5 squared, which is equals to root 30 here. So we can simplify cos theta is equals to 16 or over root 16 times root 30 here. Alright, so now theta is equals to a cos of 8 over 3 root 10. After simplifying this here, we can have 8 over 3 root 10. So our angle is equals to 32.6 degrees here, to the nearest 1 decimal place. Right, so let's go to the next example here. Alright, so let's go here. Alright, given that the points A, B, C and the line L is the equation R is equals to 2 minus 3 plus lambda 1 minus 2 here. Alright, so find the first part, find the acute angle between AB and line L. Show that the points A, B, C are collinear. Alright, so let's start with the first part here. So you can see the first part, the angle, we are interested in the direction. Alright, so a direction of the line is already there. You can just figure out here is 1 minus 2 here. This is our direction. Then the direction of AB is same as finding the vector AB. Alright, so we just find AB. This is direction 2. So AB is equals to OB minus OA. So moving from point A to a point B here is just B minus A here. Alright, so now we know that our OB is 3 minus 1, 2 minus 3 minus 4, 5 here. So now we can subtract here. So it's 3 minus 3. So a minus and a minus becomes a plus. So this is going to give us 6 here. Then minus 1 minus 4. This will give us 3 here. Then 2 minus 5. This is minus 3 here. So now we have our two direction here. So you can now find the angle. So the angle is now very simple. So cos theta is equals to the dot product of the direction all over the modulus of vector 1 direction times vector 2 direction here. So this is now going to be the dot product here is going to give us minus 6. So cos theta is equals to minus 6 from the dot product here. 1 times 6 plus minus 2 times 3 plus 2 times minus 3. This will give us minus 6 here. That the modulus here, 1 squared plus minus 2 squared plus 2 squared. This will give us root 9 here. Then for this one, 6 squared plus 3 squared plus minus 3 squared. This will give us root 54. So now theta is equals to across this value. So this value you can simplify to become minus 12 all over 3 root 18, right? So now we can now simplify here by pressing on the calculator. So make sure the calculator is in radian mode. So it's going to be across of this value, which is going to be 105.8 degrees, right? So you can see here now the value that we have here. So the angle that we have is an obtuse angle, but the question is asking for the acute angle here. So to find the acute angle, we can just subtract this angle from 180. All right, so theta is now equals to 180 minus 105.8, which is going to give us 74.2 degrees. So this one 105.8 degrees is an obtuse angle, while 74.2 degrees is an acute angle. All right, so now let's go to the other part here. All right, show that the points A, B, C are collinear. All right, so to show that the points are collinear here, so the situation will be like this. We'll be having the points A, B, and C, which are lying on the same line. So collinear points are just points that are lying on the same line here. So you can see the vector of AB multiplied by a certain constant should be equals to the vector of what? Of AC. Or the vector of AB multiplied with a certain constant should be equals to the vector of what? Of BC here. So AB is equals to KAC. So we are going to find AB and find what? AC. Then we see, is there any constant multiple that can be multiplied so that these two vectors are now equal? So let's find AB. So AB is B minus A, which is OB minus OA. We just subtract these two vectors. This is going to give us 6, 3 minus 3 here. Then AC is equals to OC minus OA. So we take our OC, which is 9, 2 minus 1, minus OA, which is minus 3, minus 4, 5. Then we subtract here. Then we get 12, 6 minus 3, 12, 6 minus 6 here. So now we need to see a constant multiple that can be multiplied such that these two vectors are equal. So if these two vectors becomes equal by a constant multiple, it means they are collinear here. Right, so 6, 3 minus 3 is equals to K, 12, 6 minus 3 here. All right, so now we can see that 6 is equals to K times 12, or 3 is equals to K times 6 here. Or minus 3 is equals to K times minus 3 here, minus 6 here. So you can just take the first part here. So 6 is equals to 12K. So K is equals to half here. So now we go back to the K equals to half and place it here and see whether the left hand side will be equals to the right hand side here. So 6, 3 minus 3 is equals to half. 12, 6 minus 3. So let's just see here. Half times 12 is 6. Half times 6 here is 3. Then half times minus 6 is minus 3. So this is proved here. So which means the points A, B, C are collinear. Alright, so another way of proving this, you can just see that this angle is a 180 degree here. So you can find the angle between AB and BC here. So if the angle produces 180 degrees, it shows that the points are what? Are collinear. Alright, so let's go to the next example here. Alright, so find the angle between line L and the x-axis, right? So this is our line L. Alright, and we need to find the angle between L and the what? And the x-axis here. Alright, so first of all, we need the direction here. So the direction of the x-axis and also the direction of the line. Right. So this equation is in Cartesian form. So let's just find the direction here. So to find the direction, we just equate to a certain lambda, then convert to the Cartesian to vector form. Alright, so this part is equals to S, and this part is also equals to S, and this part is also equals to S. So in this part we make x subject to formula, so x is equals to 2 minus 2s. Then for y here it's y is equals to 3 plus minus y is equals to minus 3 plus 3s. Then for z is equals to 4 plus the s here. So you can see that r is equals to the fixed point here plus plus s minus 2 3 1 here. Alright, so this is what we now have here. So your direction is easy. All the value that have been multiplied by the parameter here is the direction. So this is your direction here. Alright, so it's minus 2 3 1. Alright, so now we need the direction in the x-axis, right? So let's go here. So direction parallel to the x-axis. So let's go to the Cartesian plane here so that we can see. So we have the x-axis and the y-axis and the z-axis here. Alright, so a vector which is in the direction of the x-axis here will be having k 0 0 here. Alright, then a vector which is in the y direction will be having 0, k, and 0 here. Then a vector which is in the direction of the z-axis here will be having 0, 0, and the k value on the z component here. Alright, so we are interested in the direction of what? Of x here. So it's k 0 0 here. So we are going to use this one. So d2 here is going to be 2 0 0. We just take any value, the constant that we want. We can use 1, we can use 10 here, as long as it's in the direction of x here, and other component becomes 0. Alright, so now we can find the angle here. So cos theta is equals to the dot product of the direction or over the modulus here of direction 1 times direction 2. So the dot product, this will give us minus 4, or over the modulus for this part is root 14, and this one is root 2. Then now theta is equals to arc cos this value here. This is going to give us 122.3 degrees. Right, so that's how you find angles between lines. So thank you for watching the video. You can kindly share the video or in the channel, and make sure you subscribe. See you in the next lesson.